So we start out with right angle trigonometry. This picture here is extremely important. Let's take a look at it in more detail. So it's absolutely essential that it's a right triangle. There's a symbol called theta, and that designates the angle from which point of view we're going to define the trig functions. So if theta is in the lower left-hand corner here, then the side that helps form theta is called the adjacent side. The diagonal side is the hypotenuse. And then we have the opposite side from theta. So hypotenuse, adjacent, that's the side that helps form the angle. You can see the hypotenuse and the adjacent side form the angle theta. And then the opposite side does not touch the angle. Now, if theta is in the upper right-hand corner, then the hypotenuse is in the same place, but the opposite angle and the adjacent angle switch places, which means that the trig functions will be all different. Now, the trig functions are the ratios of the various sides of the right triangle, and so let's look at this right triangle here. So the sine, the function that's called the sine, is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. You can see that right here, adjacent over. And then the tangent is the opposite over the adjacent. Now, no matter how big the triangle is, if this angle is the same, then the ratio is always going to be the same. So the sine, cosine, and tangent are the same no matter, for a particular angle. They never change. The cosecant is the inverse of the sine. In other words, it's the hypotenuse over the opposite. The secant is the inverse of the sine, hypotenuse over adjacent, and the cotangent is the inverse of the tangent, adjacent over opposite. Everything that's on this page here must be memorized. This is all stuff that you need to remember. Now, let's go into example 1 here. So we're evaluating the 6 trig functions of the circle. So they give us, I don't know if you remember this, this is a Pythagorean triple. We have 5, 12, and then this side's going to be, the hypotenuse is going to be 13. Now they're putting theta in the upper left-hand corner. The right triangle is right here. Okay? So the sine, they have it right here. Opposite over hypotenuse. Okay? Here's the opposite, 12 over 13. The cosine, adjacent over the hypotenuse. Well, here's the adjacent side to theta. Helps form the angle, 5 over 13. And the tangent, opposite over adjacent. Okay, 12 over 5. Then the cosecant is the inverse of the sine, hypotenuse, 13 over 12. The secant, 13 over 5, hypotenuse over adjacent, and then the cotangent is adjacent over opposite, 5 over 12. So now we go into example 2, and they're asking us a question, a multiple choice question, which we can go ahead and answer. An acute angle of a right triangle. Well, they're both acute. Acute means less than 90 degrees. Okay, so we draw the right triangle. Now we can put theta here or up here. It doesn't matter. Okay, the sine is 4 over 7. So that means the opposite over the hypotenuse is 4 over 7. Sine equals opposite over hypotenuse. Okay, 4 over 7. So what is the tangent? Well, the tangent equals opposite over adjacent. So we got to find the adjacent side. Here's adjacent, here's opposite, and here's hypotenuse. So we're going to take, we're going to use a squared plus b squared equals c squared. Okay, so we're going to have, and b squared equals c squared minus a squared. So b is going to equal the square root of c squared minus a squared. So in other words, the adjacent side we'll call it capital A, is going to equal the square root of 49 minus 16. Which is the square root of 33. So adjacent equals the square root of 33. Okay, so the tangent is opposite over adjacent, so the tan is going to equal 4 over root 33, which we have to rationalize, multiply the top and the bottom by root 33, and it equals 4 root 33 over 33. 4 and 33 have no common factors, so this is the answer. Now, when we're giving the answers at this point in this chapter, the answers are going to be in rational and radical form, and we're not going to convert them to symbols. Now, we will be making symbols. We'll make syllables. I'm sorry. We'll be making decimals in a little bit. All right. Now let's take a look at these exercises here. We got some guided practice. Okay. So this first triangle, we got number 1. Now maybe you recognize this. Okay. It's 3, 4, 5. This is a Pythagorean triple. Okay, 3, 4, 5. So the 6 trig functions. Now theta is right here. Theta is in the lower left-hand corner. Okay, so the sine opposite over hypotenuse, and so that's going to equal 3 over 5. Cosine adjacent over hypotenuse. Okay, that's going to equal 4 over 5. Tangent opposite over adjacent. That's 3/4. And now we'll do the inverses. Okay, hypotenuse over opposite, 3 over 5. I'm sorry, 5 over 3. And the secant, hypotenuse over adjacent, that'll be 5 over 4. And the cotangent, that's adjacent over opposite, and that'll be 4 over 3. All right, let's do the next problem. So we got 17 and 15 and theta. So we're going to, in order to get the 6 trig functions, we have here 15 equals the opposite side. Here is the adjacent side, and the hypotenuse equals 17. So the square root of 17 squared minus 15 squared is going to equal the adjacent side. So let's okay, and that's going to be 8. Okay, so that's 64. The square root of 64 is 8. So the adjacent equals 8. That's another triple. Okay, so the sine equals opposite over hypotenuse, which is going to be 15 over 17. The cosine is adjacent over hypotenuse, and that's going to equal 8 over 17. And the tan is going to equal opposite over adjacent, which is 15 over 8. And the cosecant is the inverse of the hypotenuse, so that equals the hypotenuse over the opposite, which is 17 over 15. the secant, the inverse of the sine, is the hypotenuse over adjacent, which equals 17 over 8. And the cotangent equals the inverse of the tangent, that's adjacent over opposite, which is 8 over 15. Over 15. Okay, now let's do 3. And maybe you recognize what's going on here. Okay, this is 5 and 5 times the square root of 2. Now maybe you remember for a 45-45 triangle, 45-45, 90, that the hypotenuse equals the side times the square root of 2. Well, the side times the square root of 2, that's what we have for this hypotenuse, because here we have the side and the side times the square root of 2. So this has to be 5 as well. So this is pretty easy to do. We'll call this theta, but the angles are the same. So here's theta. We'll say 5 is the opposite and 5 is the adjacent, and 5 root 2 is the hypotenuse. So the sine is going to equal opposite over hypotenuse, 5 over 5 root 2, which is going to equal 1 over root 2, which is going to equal, we have to rationalize it, root 2 over 2. The cosine is going to equal the adjacent over the hypotenuse, which is going to be the same thing, square root of 2 over 2. And the tangent is going to equal opposite over adjacent, which is 1, which will also be the cotangent. Now, the cosine is going to be the inverse. Now, let's go back to here. This is probably the easiest way to talk about it. 1 over the square root of 2. So it'll simply be the square root of 2, and this will be the square root of 2 for it here. The secant will equal the square root of 2, and the cosecant. Because this is the sine right here, 1 over the square root of 2, well, therefore the cosecant will be the square root of 2, but they're the same for each one. So the cosecant and the secant are the same, the tangent and the cotangent are the same, the sine and the cosine are the same. All right. Okay, let's look at number 4 in a right triangle. Theta is an acute angle. Okay, so here's our right triangle. Let's say here's theta. We have opposite and adjacent and hypotenuse. Okay, the cosine is 7 over 10, so that's adjacent over hypotenuse, 7 over 10. So what's the sine? Well, we have to figure out what the opposite is. So the square root of 100 minus 49 equals square root of 51. So it would be the square root of 51 over 10. So the opposite equals the square root of 51. So the sine would equal the square root of 51 over 10, which is opposite over hypotenuse. All right, now this is really, really important. And I will introduce you to a method of memorizing these, but in the meantime, you need to memorize these. Whatever method works for you in order to get them down, but they're very, very important. All these angles need to be remembered. Now, if you can remember the structure of these two angles, the 30, 60, 90 and the 45, 45, 90, you're going to have a pretty good chance. 1, 1 and the square root of 2, 1, 2 and the square root of 3 for this, and they will help you to remember these angles. But we've had two things now. You need to remember the trig identities. the ratios and how they're formed, and then you need to remember these special angles. Now in example 3, you're asked to put that table to work. That is, you're asked to evaluate the length of the sides when you know the ratio, because it's one of the special angles. In other words, for 30 degrees. Now look how this is solved. So the cosine of 30 equals adjacent over hypotenuse. Now what are we doing here? We're looking for x. So, and we know the hypotenuse. Now the x is the adjacent. Now here's an angle. You're given an angle 30 degrees. Now you know the special, you know all the trig functions for that equal. But which one do you use in order to find x? You could use the sine, the cosine, the tangent. You want to use the trig function that combines what you want to know, which is x, which is the adjacent side, with what you know, which is the hypotenuse. So that would be the cosine, because the cosine combines the adjacent side with the hypotenuse. It combines what you want to know with what you know. So you can make an equation. The cosine of 30 degrees equals adjacent over hypotenuse. The cosine of 30, as you know from the table, you can go and look at it, is the square root of 3 over 2, which equals x over 8. So then you multiply both sides by 8, so x equals 4 times the square root of 3. And you can use your calculator to come up with a decimal approximation for that, or simply leave it in radical form. So, using trigonometry, using the trig functions, you use it to find all the unknown information about a triangle. Now, solving a triangle means you find all 3 sides and all the angles. Now, it's usually one angle to find, but there could be as many as 2 sides. And we're going to use the calculator in order to do this. So let's see if we can figure out what the guy's doing here, what the book is doing. So we have to find, we're given angle A. By the way, let's just talk about the labeling of the angle, of the triangle. Okay. We have capital A, capital B, and capital C. These capital letters refer to the 3 angles. So we have angle A, angle B, and angle C. C is always the right angle. And then we have little a and little b and little c. Now, these refer to the sides, the lengths of the sides, and they're always opposite the angle that they share the letter with. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So in order to solve this triangle, we're given B equals 15, and we're given A equals 28 degrees. We have to find angle B and sides A and C. Now there's a whole lot of different ways to do this based on what you've been given. So we can, first thing we can find is we can take 90 and subtract 28 from it and get 62 degrees. Why? We know that these 2 angles have to equal 90 degrees because all the angles in a triangle add up to 180. So we've already got 90 here, we got 28 here, so there must be 62 here. Now, from this point on, we're finished with angle B. So we want to find let's say we want to find side A. Okay, we know side B, so we know the adjacent. A is the opposite, and B is the adjacent in reference to angle A. So we can use the tangent, and you can see the guy here says the tangent of 28 equals opposite over adjacent. That's going to be a over 15. Now you can get the tangent of 28. Let's do that in the calculator. Now the first thing you got to do is you got to go to mode and make sure that you're in degrees instead of radians. So we're going to go to mode and make sure we're set for degrees. And then we're going to get out of here. Okay. Now, the tan of 28 equals a over 15. 15 times the tan of 28 equals a. So we're going to do 15 times, and here's the tan of, and we'll put in 28. That's 28 degrees. And so we're going to get 7.975. Call it 7.98. So side A equals 7.98. Now the only thing we have left to find is side C. Now look what they do in the book. In other words, we want to find the hypotenuse. Now the secant is the hypotenuse over the adjacent. Now we know the adjacent and we don't know the hypotenuse. Now we could also use the cosine to do this, adjacent over hypotenuse. But by using the secant, we're making it slightly easier because we're putting the variable into the numerator. So the secant of 28 is going to equal the hypotenuse, C, over 15. We multiply both sides by 15 and we get 15. Now, notice that we do not have a secant function on the calculator. All we have is sine, cosine, and tangent. But we can do 1 over the cosine of 28, and that'll give us the secant. So we'll do 15, and then we'll do times 1 divided by the cosine of 28, close parenthesis, close parenthesis. Okay, and we'll call that 16.99. Now the book calls it 17, which is fine with me. Okay, so we've solved the triangle. Solving the triangle means finding all three sides and all three angles. So now we're going to do some guided practice here. So let's do some guided practice. Now they give us a triangle that we're working on, okay? But we don't have to, well, we got a 45-degree angle. So let's kind of draw a triangle. I'm going to draw one that looks a little bit more like that. So it's 45, 45, 90. So we know that, so what do they give us? A, hold it. So here's angle B, here's angle, and here's C. So side C, this is 5. Okay, so the hypotenuse is 5. Now, we know that the side times the square root so finish, we got side B and we got side A. Alright, now what do we know? We know that the sine of A equals opposite. It's going to equal A over C, which is the square root of 2 over 2. So square root of 2 over 2 equals B over 5. So B equals 5 times the square root of 2 over 2. Now A is going to equal the same thing. So that's number 5. Now 6. So we got A, B, and C. And B equals 10, and C equals 32. All right, now the tan of A is going to equal opposite over adjacent, which equals A over B, which equals A over 10. So the tan of 32 equals A over 10. So A equals 10 times the tan of 32. And we put that into the calculator. Okay, so I should have kept that up on the screen here. Let me bring that back. Yeah, I'll take a picture of it. About 6.25, let's call it. So A is 6.25. Now C, the sine of 32 equals, no, let's do cosine. Let's do the adjacent. The cosine of A equals B over C. So the cosine of 32 is going to equal 10 over C. So C will equal 10 divided by the cosine of 32. And C will approximately equal, we go back to the calculator, divided by the cosine of 32. About 11.8. Okay, and that triangle is solved. All right, 7. Same thing, okay. A, B, C. C is the right angle. Little a, little b, little c. Okay, A is 71 degrees, and C is 20. Okay, now we want to find B and C. The cosine of A equals B over C. So the cosine of A, the cosine of 71 equals B over 20. So B equals 20 times the cosine of 71. So let's call it 6.5. I guess that's 6.5. 6.5 is good enough. Okay, and A is the sine. So the sine of A equals A over C, which equals A over 20. So the sine of 71 equals A over 20. A equals 20 times the sine of 71. Okay, so that triangle. Oh, and then the other angle is going to be 90 minus 71, which would be 19 degrees. All right. Now, we got here. We got one of our special angles. So we got our triangle. All right, and so angle B is 60 degrees, and A equals 7. Now, let's go to the previous page, and let's look at our trig functions for B. You can see I haven't memorized them. I haven't looked at them in a while. Okay, so B. So for B, for 60 degrees, the sine of 60 equals root 3 over 2, and the cosine equals 1/2, tangent equals root 3. Okay, so we can use all these to find the sides that we want to find. All right, so let's go back to the other page. Here we go. All right, so what can we figure out here? So let's find the hypotenuse. The cosine is 1/2, so the cosine of B equals A over C, which equals 1/2. So the cosine of B equals 1/2. Equals 7 over C. So C has to equal 14. Now we're going to get into this. Okay. Now what about B? Well, the sine is the square root of 3 over 2. Now we know that we're pretty good about 14. So the square root of 3 over 2, which is the sine of 60 degrees, is equal to B over 14. So B will equal 14 times the square root of 3 over 2. So B is going to equal 7 times root 3. Okay, so that's finished, and this is 30 degrees, obviously. So 7 root 3. All right. Let's also look at this word problem. It's kind of interesting. If you've read it, you realize you started out right here. Now, what's your goal? You want to find the distance from here to here. Now, you measure a 90-degree angle, and you go off at 90 degrees this way for 2 miles. Okay, so you want to find the distance from here to here, but you don't want to walk all that, or maybe you can't walk it because it's in the Grand Canyon, I guess. So you want to know like the difference from here to here, but you can't. But you can walk from here to here. So you establish a right angle by some means. We don't know how you do it, and you walk 2 miles this way, and you take another sighting of the same point. Now, when you looked at this point from here to here, this is a 90, you went off at 90-degree angles. Now you're looking at it, the angle at which you look at it is 76 degrees. So you've made a right triangle with 76, and what this is, 14 degrees here, and this is 90 degrees here. Now if you want to find this distance, what do we have here? Your angle, here's theta. Theta is 76 degrees. Well, what do you know? You know the adjacent side, that's 2 miles. Well, what do you want to find? You want to find the opposite side, this side right here. Okay, so you know that the tangent of 76 degrees is going to be the opposite over adjacent. And the opposite is what you want to find, x over 2. So 2 times the tangent of 76 is going to equal x. So x equals 8, about 8 miles. So it's 8 miles from here to here. Okay, that's example 5. Now let's look at what 6 does. Okay, we have angle of elevation and then angle of depression. Okay, so here you're looking up, the angle at which you look up at something is the angle of elevation. The angle at which this line is coming down from this line up here is called the angle of depression. Okay, these angles have the same measure, and you probably remember this from geometry. Alternate interior angles. The angles of elevation and the angles of depression are alternate interior angles. This line up here and this line down here are parallel. So you have a diagonal connecting them, and you have alternate interior angles, called now the angle of elevation and the angle of depression. So here's a parasailer. Okay. Now his angle of elevation is 48 degrees, and he's tied with a rope 300 feet long. How high is he above the boat? Okay, so the height would be his height perpendicular from the water or whatever, and that would be h here. So what do we know? We know the angle of elevation, that's 48 degrees. We know the hypotenuse, 300, and we want to know the opposite side right here. So the sine of 48 equals h over 300. 300 times the sine of 48 equals h. His height is 223 feet. Obviously, we use a calculator to do that, as we were doing in the previous examples. Now, what do they want to do now? They want you to find the distance from Powell to Wilberforce. Okay, well, let's scroll down. How would we do that? Okay, now here's our triangle. Let's see if we can kind of duplicate it here. This is a right angle. Okay, this is 76 degrees, and this is 2 miles. Now we found this, but what we want to find is this. Okay, we want to find, let's call this, I don't know, Z or something. Okay, well, what we want to find is Z, and what we know is the adjacent. So we have the adjacent and the hypotenuse. Well, what relationship relates the adjacent and the hypotenuse? Well, that's the cosine. The cosine equals adjacent over hypotenuse. So the cosine of 76 degrees is going to equal 2 over Z. So Z will equal 2 divided by the cosine of 76 degrees. So we get out the calculator, and we'll take 2 divided by the cosine of 76. And that's 8 points. So, which it makes sense. It's slightly bigger than the opposite side. It's the hypotenuse, so it should be the longest side. Let's call it 8.27 miles. Okay? Alright, so that makes sense. Now, let's look at the other question here. What if, estimate the height of the parasailer above the boat if the angle of elevation is 38 degrees? Well, it would just be 300 times the sine of 38. I don't know if, so 300, if it was 38, it would still be 300 feet. So it'd still be 300 times the sine of 38. Okay, so it would be lower, which makes sense. It'd be about 185 feet. Alright, so let's see what's next. Exercises. Alright, so we're done.